Let's today study the conversion of infix to a postfix expression using stack. Now quickly let's have a look at what is infix and postfix expression. When we say it's infix expression, does mean operator would be between two operands. That is the normal expression we write like a plus b, 2 plus 3 and so on. Now when I talk of a postfix expression is one wherein operator would be at an end before we write an operands, and at an end we will be writing an operator. So if you convert your a plus b infix expression to a postfix one, it would be something like ab plus. Now let us have a look at rules to convert this infix expression to a postfix expression using stack. Now first is whenever you come across a symbol open, you have to add directly to a converted expression or to an output window. Now when you come across a closed parenthesis, you have to pop all the stack symbols out of a stack until you get an opening parenthesis. If a symbol that you come across is an operator, in that case you have to check for in stack priority and incoming priority of the symbol, and depending upon that you'll be pushing an operator onto a stack. Now for this we have to follow some rules. That is, in stack priority we will be checking for the symbol which is already onto a stack, whereas incoming priority would be for the symbol we are currently looking at, and we have to compare the priorities of both the symbols. Now when I say that I have got some symbol with higher priority on a stack, I cannot insert a symbol with low priority onto a stack. So this is not allowed. But if you have some low priority symbol into a stack, you can always insert a high priority symbol over it. So that is allowed. Right? When you reach at an end of input, you have to pop all the elements out of a stack and we have to add it to an expression. Now let us have a look at a precedence table which we have to follow for converting this expression. Now for a symbol say plus, I'll be checking for in stack priority if plus is already lying onto a stack, and incoming priority would be checked for all symbols when you are about to insert that particular symbol onto a stack. Let's have a look at an example so as to have a clear idea. This is my infix expression with parenthesis I have taken. So the first symbol here, we are going to iterate over this infix expression symbol by symbol. That is, the first symbol that we are going to come across would be starting parenthesis, opening parenthesis rather. So when you come across an opening parenthesis, we have to go for checking its incoming priority. So incoming priority, as in the table you can see, the incoming priority is 9, does mean it is the highest priority symbol. So irrespective of what is lying on the stack, we can anytime insert this onto a stack. So we are inserting that starting parenthesis onto a stack. The next symbol I am coming across is an operand. Whenever you come across an operand, you have to directly write it to your postfix array. So that's what we did, followed by the next symbol which is plus. Now incoming priority and in stack priority comes into a picture. Now plus is a symbol for which I need to check incoming priority, because that is the symbol required to be inserted or pushed onto a stack, whereas I have the opening parenthesis lying already onto a stack. So for opening parenthesis we will be checking its in stack priority which is 0, and plus is a incoming symbol, so we will be checking its incoming priority. So whenever you have some symbols onto a stack with a low priority, anytime you can insert the symbol with high priority over it. So the symbol that is in a stack is having a priority 0, whereas incoming symbol has the priority 1. So we will be able to insert plus over a open parenthesis. Now the next symbol that we come across is B. B is an operand, so without checking for a stack condition, we'll have to directly write it to a postfix expression. The next symbol that we come across is minus. Now the symbol we'll have to check for is plus ka we will be checking for in stack priority because it is lying in a stack, whereas for minus we will be checking for incoming priority because that is going to be an incoming symbol. So the priority of plus is 2 whereas that of minus is 1. So a high priority symbol is lying already onto a stack, so we will not be able to insert or push minus over plus. So for that we have to pop plus out before we push minus. Now in this case we have got only one value that is required to be popped out because below plus we have got an opening parenthesis whose in stack priority is 0. So over this we can push any operator. Fine. So here there is no issue, but in some cases you may need to pop multiple elements out of stack before you push your current symbol onto a stack. Let us have a next symbol which is C. C is an operand, so we will directly move it to an postfix expression. The next symbol that we come across is a closing parenthesis. Whenever we come across a closing parenthesis, we have to pop everything out of a stack unless and until we get opening parenthesis. So that's what we are going to do. We'll pop minus out. Whatever thing is popped out will be moved to a postfix array, followed by which we will pop out the opening parenthesis, and that leads to an ending of stack, or now our stack is empty. The next symbol that I come across is star. So as just because the stack is empty, we can push this star onto a stack. So we'll be pushing this star followed by the next symbol which is D. It's an operand, so we will move it to an postfix vector. Followed by the next symbol which is minus. Now we will check for in stack priority of star which is 4 and incoming priority of minus which is 1. So the high priority element is already lying on a stack, so over that I cannot push a symbol with a lower priority. So I have to pop that star out first so as to create a space for minus sign. So star is popped out and is moved to an postfix array, followed by the next symbol that is an opening parenthesis. When it's an opening parenthesis, its incoming priority we will be checking for which is 9, and in stack priority of a symbol which is lying onto a stack which is minus is 2. So for that purpose we can easily push this bracket onto a stack because it has got the higher priority. Now the next symbol that we come across is E, which is an operand, so we will be directly moving to a postfix array, followed by plus. Plus is a symbol whose incoming priority is required to be checked. Its incoming priority is 1, whereas in stack priority of an opening parenthesis is 0. So I can push this plus onto a opening parenthesis, followed by a next symbol that is F. F is an operand. It is directly required to be moved to a postfix array, followed by an closing parenthesis. Whenever we come across a closing parenthesis, we have to pop everything out of a stack unless and until we get an opening parenthesis. So we pop plus out of a stack, followed by which we will get opening parenthesis. Now just because it is an end of expression, we have to pop all the elements out of a stack. Here in this example we have got only one element to be popped out, but if multiple elements are lying on a stack, we have to pop everything out of a stack and we have to append it to a postfix array. So this is an example. Now specifying it in the manner it was shown previously is quite difficult. So while solving a problems, we will be creating a table of 3 columns: first one for symbol, second one for stack, and third one for postfix expression. And symbol by symbol we will process it, and we will write it in this manner. So the first symbol we come across is 3. So 3 is an operand. We will directly write it to a postfix expression. Next symbol that we come across is plus. Right now your stack is empty. We have to assume that stack is open on right hand side. Fine. From there we are going to push an element onto a stack. So a plus is pushed onto a stack, followed by the next symbol 8. There won't be any change in a postfix expression up till now. When I come across the next symbol 8, of course this is an operand, so it is required to be appended to a postfix expression. So that is done. In this step there won't be any change in a stack, followed by which the next symbol that we come across is a divide. So divide is having a priority higher than plus, so we will be able to push it onto a stack. Plus has got low priority, whereas the divide has got higher priority, so this is allowed, and there won't be any change in a postfix expression, followed by which the next symbol that we come across is 2. So there won't be any change in a stack position, whereas 2 gets added to a postfix array. The next symbol is minus. Now we have to check for incoming priority of minus and in stack priority of division sign. So division has got higher priority, so we will not be able to push minus onto a stack. So we have to pop division out of a stack. When we pop division sign out, we can see we have to again compare the in stack priority of plus sign with incoming priority of minus. Again we will not be able to push that minus over a plus, so we have to pop both the elements out of a stack in a sequence. First we will pop out divide, followed by plus, because that was inserted in the same sequence. Once we are done with that, our stack would be empty and we will be able to push that minus sign onto a stack, followed by which the next symbol that we come across is 1. So there won't be any change in the stack position, whereas 1 gets added to your postfix expression. Next is a star symbol, which is a multiplication sign. Again we will check for the priority of minus and multiplication. For multiplication we have to check incoming column, whereas for minus we have to check for in stack column. Just because this is having a high priority than minus, we will be able to push it over a minus sign. So there won't be any change in the postfix expression, followed by operand once again. So whenever we get an operand, we have to directly move it to a postfix expression. Now this is an ending of a expression. Now at an end of expression, what we have to do is we have to pop everything out of a stack. That is, star gets popped out first, followed by minus sign. So this is an ending of converting an infix expression to a postfix one. Hope you liked my video. Subscribe to my channel for more videos on data structure and algorithms. Thank you.